All right, so let's look at an example of using this molar mass for a conversion. If I wanted to use 0.115 moles of calcium phosphate in a chemical reaction, I'd want to know how many grams would be equal to that 0.115 moles so I could measure out the grams. So we're going to treat this like any other conversion. We're going to set it up where we look at what we're given the 0.115 moles of calcium phosphate. What are we trying to find? We're trying to find grams of calcium phosphate. Pretty straightforward, this one. So what are we going to do? We're going to take moles of calcium phosphate, convert to grams of calcium phosphate. What's the relationship we're going to use? Well, we're going to use the molar mass of calcium phosphate. So we need to calculate that. Now if you want, you can pause the video, try to calculate on your own, check your answer with mine. I'm going to go through step by step here for the molar mass calculation though. So we're going to start with 1 mole of calcium phosphate. Let's deal with the calcium side first. So 1 mole of calcium phosphate, based upon that formula, would have 3 moles of calcium in it, right? Ca subscript 3 means we got 3 moles of calcium. Each mole of calcium is going to be 40.08 grams of calcium. I get that from the periodic table. Remember, look at the units though. Set these up so that the units are canceling to keep track of things. Don't try to take shortcuts, otherwise you're going to get the wrong answers. All right, so when I multiply all those out, I get the 120.24 grams of calcium. I can then do that with the phosphorus, and I end up with 61.94 grams of phosphorus. I can do that with the oxygen, and I end up with 128.00 grams of oxygen. And when I add it all up, I get 310.18 grams. That is now going to be the molar mass of my calcium phosphate. Remember too, don't forget when you're doing these things to pay attention to the significant figure rules. Alright, so we know the molar mass is 310.18 grams per mole, and that's grams of calcium phosphate per mole of calcium phosphate. We know that's our relationship we're going to use to do the conversion. So now let's actually carry out the conversion. So I'm going to start with my moles of calcium phosphate. Put moles of calcium phosphate on the bottom, grams of calcium phosphate on top. And I know based upon my moles of calcium phosphate canceling, I'm going to end up with grams of calcium phosphate. I just want to make sure my units are canceling. Now I can go back in and put in the numbers, and I end up with 35.6707 grams of calcium phosphate. Don't forget to pay attention to the significant figures. Always be keeping track of those. So I have 0.115 has 3 significant figures. 310.18 has 5 significant figures. So therefore my final answer is limited to 3 significant figures. So 35.67 gets rounded to 35.7. So now don't forget, we always want to give a rough check of our answer. Does it seem logical? If we have 1/10 of a mole of something that has a mass of 310 grams, that we end up right around 30 grams, yeah, it seems reasonable. You could also go back and plug in numbers back in our calculator, double check them again too. Okay, so we're going to look at a slightly different type of calculation, but it's going to have a lot of similarities. So this time around, we're going to calculate how many atoms of calcium are in the 0.115 moles of calcium phosphate. We're given 0.115 moles of calcium phosphate. We need to find atoms of calcium. So to do the conversion, our conceptual plan will go from moles of calcium phosphate to moles of calcium, then from moles of calcium to atoms of calcium. To do the moles of calcium phosphate to moles of calcium, we just need the formula, which we have. To do the moles of calcium to atoms of calcium, we're going to need Avogadro's number. So we can set it up with the moles of calcium phosphate. And we've got 1 mole of calcium phosphate to 3 moles of calcium. We've got 1 mole of calcium to 6.022 times 10 to the 23rd atoms of calcium. Make sure our units are canceling. We end up, when we plug those numbers into our calculator, we end up with 2.07759 times 10 to the 23rd atoms of calcium. Now, when we look at significant figures, 0.115 has 3 sig figs. The 3 moles of calcium to 1 mole of calcium phosphate, since that's a conversion based upon a formula, those are exact numbers. We don't include those. When we look at Avogadro's number, we have the 6.022 times 10 to the 23rd. That's got 4 sig figs. So the first number had 3, Avogadro's number has 4, so our final answer should have 3. So we run that to 2.08 times 10 to the 23rd atoms of calcium. Then we need to check our answer. Does it make sense? Well, so if we have Avogadro's number and we take 1/10 of it from the 0.1 0.15 moles. That'd give us 0.6. 0.6 times 3, 1.8 roughly, so 2 times 10 to the 23rd. Yeah, that seems reasonable. Once again, that's the way I check things. You can check them however you wish to, but I just like to do a quick rough calculation just to double check I don't have a really large number or a really small number that seems wrong. We're going to look at a calculation that adds one more step onto this. We're going to look at how many atoms of phosphorus are in 353.75 grams of calcium phosphate. So, what are we given? 353.75 grams of calcium phosphate. What are we trying to find? We're trying to find atoms of phosphorus. So, our conceptual plan. Grams of calcium phosphate to moles of calcium phosphate, then moles of calcium phosphate to moles of phosphorus, and then moles of phosphorus to atoms of phosphorus. So, what are we going to need to carry out this conversion? Well, to go from grams of calcium phosphate to moles of calcium phosphate, we're going to need the molar mass. To go from moles of calcium phosphate to moles of phosphorus, we can use the formula. And to go from moles of phosphorus to atoms of phosphorus, we're going to need Avogadro's number. All right, let's run the calculation. We've got 353.75 grams of calcium phosphate. Now, because I want to get rid of grams of calcium phosphate, my grams of calcium phosphate go on the bottom in the next step. That way my units cancel. Put my moles of calcium phosphate on top. That relationship is my molar mass. The next step, moles of calcium phosphate go on the bottom because I want to cancel out my moles of calcium phosphate. Moles of phosphorus go on top. Next step, moles of phosphorus go on the bottom so that my moles of phosphorus cancel. And atoms of phosphorus go on top. That would be Avogadro's number relationship. And then I take the 353.75 divided by 310.18 times 2 times the 6.022 times 10 to the 23rd, and you end up with 1.37357 times 10 to the 24th atoms of phosphorus. So in looking at all the values again, I should have 4 significant figures in my final answer. So I should end up with 1.374 times 10 to the 24th atoms of phosphorus. Okay, so now, to check my answer, does that number make sense? Well, if 1 mole of calcium phosphate weighs 310 grams, and I've got 353 grams of calcium phosphate, I'm right around 1 mole. And for every 1 mole of calcium phosphate, I have 2 moles of phosphorus. Then I should have roughly twice the amount of Avogadro's number, which I do. So, yeah, it makes sense. All right, so you're starting to see a theme here where we're going from grams to moles, moles to moles, moles to atoms, or moles to grams, or something other along those lines. You're starting to see important conversion factors that we use in chemistry all the time, like molar mass. So let's look at a final example of this. We want to calculate how many grams of oxygen atoms are combined with 3.10 grams of phosphorus atoms in calcium phosphate. Let's look at the given. I'm starting with 3.10 grams of phosphorus. Right. Keep in mind, when you're reading these questions, make sure you pay attention. Simply because the word atom is in there doesn't mean I'm necessarily looking for atoms. Okay, it's just talking about a mass of atoms. Okay, in this case, we're starting with the grams. What are we trying to find? We're trying to find grams of oxygen. Conceptual plan. Well, we're going to have to go from grams of phosphorus to moles of phosphorus to moles of oxygen to grams of oxygen. So how are we going to do that? Well, the grams of phosphorus to moles of phosphorus we can do with our molar mass, the 30.97 grams per mole. The moles of oxygen to grams of oxygen we could do with the molar mass of oxygen. We might want to think about Avogadro's number. And we're going to get the moles of phosphorus to moles of oxygen ratio is going to come from the formula. So 2 moles of phosphorus over 8 moles of oxygen, or 8 moles of oxygen over 2 moles of phosphorus. That particular conversion only works for this particular compound though. Okay, remember it's coming from the formula. If we had a different formula, that ratio would be different. All right, so let's set up our solution then. So we're starting with grams of phosphorus, converting the moles of phosphorus, put the grams of phosphorus on the bottom in the next step, so our grams of phosphorus cancel. We then put our moles of phosphorus on the bottom of the next step, so that our moles of phosphorus cancel. And then we put moles of oxygen on the bottom of the next step, so that our moles of oxygen cancel. When we plug those values in, we get 6.406 grams of oxygen, but we're limited to 3 significant figures because of our 3.10 grams. So we end up with 6.41 grams of oxygen. Okay? Then once again, does it make sense? Does it seem reasonable? And yeah, it does. We're not ending up with an extremely large amount of oxygen. We started with 3 grams of phosphorus. We ended with 6 grams of oxygen. That seems reasonable. Okay, we could go through and run the calculations again. So in looking at this, what happened to my Avogadro's number? Atoms is in the problem, right? The word atoms is in the problem, so why didn't I use Avogadro's number? Well, I didn't need to. Right? So even though I tossed it in the relationship, keep in mind, writing out those relationships is just brainstorming, coming up with some ideas. You don't necessarily have to use everything you wrote down. You need to decide whether to use it or not. And keep focused on what units you're looking for. In this case, the word atoms was in the problem, but I didn't actually need to convert to atoms. If it had asked how many atoms of oxygen are combined with 3.10 grams of phosphorus atoms in calcium phosphate, then I would have done the same solution, except at the very end, then I would have converted my moles of oxygen to atoms of oxygens instead of grams of oxygen. So some common themes were running through all of this stuff. When we were dealing with grams, which is a macroscopic property that we can physically measure in the lab, and dealing with moles, which is going to get to the molecular side of things when we convert moles to atoms with Avogadro's number. But a lot of times we're going to see this grams to moles, moles to moles, moles to grams kind of situation in later calculations. All right, so if we want to convert between grams and moles, we're going to use our molar mass. If we're going to convert between moles and moles, we're going to use a mole-to-mole ratio, either from a chemical formula, or later on we'll be using a balanced equation. And then we can convert from moles back to grams using a molar mass. Keep in mind though, we can never convert from grams of one compound to grams of another compound directly. The only relationships that we can have are between the moles. Remember, we can have moles equal to each other, but the masses are going to be different. 1 mole of oxygen was 16 grams of oxygen inside the balloon, whereas 1 mole of water was 18.02 grams of the water in the graduated cylinder. So keep this concept in mind whenever you're thinking about doing these calculations. Also, keep in mind, you notice through all these calculations, I used that general setup I showed you the first time we were dealing with unit conversion. Keep using that. It helps you keep things organized, it helps you get a plan of attack, and it's going to help you get the correct answer more often. And also pay attention to the units. Make sure your units are canceling. Write things out the way I'm showing you. Don't take shortcuts. A lot of times when people take the shortcuts and they don't write all the units, they miss a step, they miss something, and they end up putting the wrong numbers in the wrong place. They get the wrong calculation, they get the wrong answer. Everything gets messed up. Okay? Get specific with your units. And you notice in all of these, I didn't just write grams and moles. I wrote grams of calcium phosphate, moles of calcium phosphate, grams of oxygen, moles of oxygen. I got specific. Do that as well, because if you just write grams and moles, if I just have MOL for a unit, then one MOL may cancel out with another MOL. And it looks like my moles of oxygen would cancel out with my moles of phosphorus when they don't. So get specific with those. It's going to help you out in the long run.